Okay. We want to solve a right triangle. We want to solve problems involving bearings. And we want to model simple harmonic motion. You guys know what a right triangle is. That's a right triangle. It has three vertices, capital A, capital B, capital C. The opposite sides from the vertice is going to be the lowercase letter. This will be side A, that will be side B, that will be side C. Okay? What we're going to do now is solve these things involving degree measure and also radian measure. You are going to use calculators for this one. Okay? You can't do anything that's not one of the angles on the unit circle right now using anything but a calculator. However, in the next chapter, when we start introducing trigonometric identities, then you get to solve these triangles using trig identities and no calculators. Okay? So, in figure 4.1 on the previous page, which is going to be what I drew up there, let angle A be equal to 62.7 degrees and let little a be equal to 8.4. Solve the right triangle, rounding lengths to 2 decimal places. Okay, if A is equal to 62.7, and let's just, I'm going to redraw the triangle. So A, B, C, little a, little b, little c. And if A is 62.7 degrees, that means that angle B right here is going to be equal to 90 minus 62.7 degrees because they are going to be complementary because angle C is 90 degrees. So this is minus 62.7 degrees, and that's going to give me 27.3 degrees. Now, I know that side A is 8.4. This is equal to 8.4. I need to know the other two sides. The only way to do this is with trigonometry. Okay? Knowing that side A is 8.4, let's go ahead and find the tangent of 62.7 degrees, which is going to be equal to 8.4 divided by the adjacent side. In other words, the adjacent side, and when I say adjacent, let's go ahead and actually use the letters from the triangle, little b. That means little b is equal to 8.4 divided by the tangent of 62.7 degrees. Carry your calculations out to 4 decimal places. You can then round off to a single decimal place at some point after you've done all your calculations. Now, why is b equal to 8.4 over the tangent of 62.7? Well, because you multiply both sides by b, divide both sides by 62.7. It's really more because that is a proportion. These are called the means, these are called the extremes. In a proportion, you can interchange the means and you can interchange the extremes. And you do not change the value of the proportion. So then go ahead and do that actual division. Make sure that your calculator's set in the right mode. And this one is going to be in degrees. So then we do 8.4 divided by the tangent of 62.7. And I get this. B is equal to 4.3356. Do not round it off yet because I still need to find C. I could round it off and say B is equal to 4.3, but I want to use this in my actual calculation. Okay? So how do I find C? How do I find little c? Yes, Jesse. I can use the Pythagorean theorem. What else could I do? I could use trig, right? I could do the sine of 62.7 is equal to 8.4 over c. I don't really care which way you go. What else could I do besides that? I could do the cosine of 62.7 degrees is equal to 4.3 over c. But what did I say about calculations? Leave it as 4.3356. Or I can do c is equal to the square root of a squared plus b squared, which will be equal to the square root of 8.4 squared plus 4.3356 squared. Now, here's the question that I'm going to ask you. Of those three methods, which one do I actually want to use? Let's see. I'm going to pick somebody. Taylor, right? Which one of those three methods do I want to use?
I would do the easiest one, is Pythagorean, but the last one.
This one?
Yeah.
So, you would rather go with this one, but you're picking that one. Is that what you're saying?
But we can do any of them, right?
You can, but what I'm asking is which one is the preferred of the three? Exactly. What's going to happen if I use either two of these methods, the cosine or the Pythagorean theorem? Round off error, yes. Round off error rears its ugly head. Go with the first one because, as he said, 8.4 is given in the problem. That is an exact value. The decimal angle is given in the problem. So go with the sine of 62.7 equals 8.4 over c. If you do the other two, yes? No? Oh, no. No. Because sine is opposite over hypotenuse, right? We're looking at this angle right here. I don't care about the other angle right now. I could have used it because I subtract from 90 and get an exact value, but I'm not using it. Okay? Oh, okay. All right. But we're going with A because, once again, that was given in the problem. That's always going to be my key. What values are given in the problem? Use those more than the others, if at all possible. Your answers from this one, and this one are going to be really close. Okay? And we're probably talking hundreds or thousands in the difference. Doesn't really matter. But in this course, no big deal. But when you're looking at tolerances of 10 thousandths, it is a big deal. And you will be looking at tolerances like that depending on what you're doing. All you got to do is ask anybody who deals with computers. When you start getting down and looking at those circuit boards, you start looking at what's on a microchip, the processor itself, yeah, that's what we're talking for tolerances. So it's important to understand round-off error. Okay, and I have no idea what this is actually equal to, so that's going to be C is equal to 8.4 over the sine of 62.7 degrees, so 8.4 divided by sine of 62.7, and I get C is equal to 9.4529, which I will round off to 9.5. There you go. I've just completed the triangle, and that's what you're going to do. Okay? Any questions? Now, why is this important? Well, we already started to address this in a previous section because we're going to do this. From a point on a level ground 80 feet from the base of the Eiffel Tower, the angle of elevation is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. Okay, a couple things about this problem. First off, all I got to do is Google the height of the Eiffel Tower, and I get it to an exact measurement. But let's just say, for the fun of it, that I don't have Google available. And so I'm going to break this down. I know that I've got the Eiffel Tower, right? It doesn't really matter what it looks like. I want to know how high this thing is, right? I am standing where? I am standing 80 feet, and it's going to be from the center of the tower. And I'm going to look up at the tower, and my head is going to be elevated at an 85.4 degree angle. And I'm trying to find the height of the tower. Okay? That's going to be the opposite. So what trig function am I going to use? Tangent of 85.4 equals opposite over adjacent. Right? So that means that 80 times the tangent of 85.4 degrees is equal to the height of the Eiffel Tower. I go ahead and calculate that, and I'm going to get the fact that the height is equal to 994.306, and it goes on. I don't remember what the fourth number was because I didn't write it down. 80 times the tangent of 85.4. 4. There's a 4 there. So, like I said, we carry it out 4 decimal places, but then it says round it off to the nearest foot, which means that the approximate height, and it is approximate, of the Eiffel Tower is 994 feet. Okay? That's how we use right triangle trigonometry. These problems are done exactly the same way every single time. For example, a guy wire is 13.8 yards long, attached from the ground to a pole 6.7 yards above the ground. Find the angle to the nearest tenth of a degree that wire makes to the ground. It's the same exact problem. There's no difference in how you set this thing up. A guy wire is 13.8 yards long, which means that I've got a guy wire that is 13.8 yards long. It's attached to a pole 6.7 yards above the ground and from the ground. So right here to right here. Okay? This is 6.7 yards. Find the angle to the nearest tenth of a degree that the wire makes to the ground. I'm going to assume this is at a right angle. It doesn't tell me that it's at a right angle. That's a problem with this initial exercise. That's an assumption that I have to make. And since we're dealing with a section on right triangle trigonometry, we're going to make that assumption. In the field, could I make that assumption? No. Okay? Rarely are poles stuck in the ground at 90 degrees. And even if they started out that way, because of the way the earth shifts and wind and the whole bit, they rarely stay at 90 degrees. Yes, what are you going to say, Jesse? It's talking about where the wire is attached. It's attached to a pole 6.7 yards above the ground. It's a bad question. It really is. This comes straight out of the textbook. It's a bad question. There's a lot of things wrong with the way it's written, but this is what they're looking for. On the test, trust me, my questions are a lot better than this. Some of them are open to ambiguity and interpretation. Okay, I could say this pole is 6.7 yards above the ground. It's worded in poorly. Okay, hey, it's a math class. If you want grammar, go over to the English building in Harris Hall. Okay, no, seriously. But this is what we're looking for. So what do I need? I need the angle theta here, and therefore I have the opposite. I have the hypotenuse. So I'm going to use what trig function? Sine of theta is going to be equal to 6.7 over 13.8. However, in order to get theta, I need to take the inverse sine of both sides. That means that theta itself is equal to the inverse sine of 6.7 over 13.8. And when I calculate that, I get theta is approximately equal to 29.0457. That says to the nearest tenth of a degree. So theta is going to be 29.0 degrees, or just 29. It's a word problem. The angle between the wire and the ground is approximately 29 degrees. That's how you're going to answer that one. Now, in my math lab, you're just going to type in the angle measurement, obviously. Paper and pencil test, that's what you want to do. Now comes the fun one. You are standing on level ground, 800 feet from Mount Rushmore, looking at Abe's face. The angle of elevation to the bottom of the sculpture is 32 degrees, and the angle of elevation to the top is 35 degrees. How tall is Abe's sculpture to the nearest tenth of a foot? Now, when you look at this one, a couple problems jump out at me. First off, it's saying the angle of elevation is 32 degrees. Okay. My angle of elevation is going to be decidedly different than, well, let's use Taylor for an example, because she's shorter than me. Right? Doesn't tell me how high off the ground the angle of elevation is. So what should I assume? And I'm lying on the ground looking up at Abe's face. Yeah, that should be in there. But for right now, we're just going to assume the angle of elevation is from the ground. Okay? We're going to get more complex as we move along. So how do I do this problem? Well, if I'm down here and I'm looking up at old Abe's face, whatever it looks like, what do I note? I note that if I look to the bottom of the sculpture, we're looking at a 32-degree angle. And I note that if I look at the top of the sculpture, we're looking at a 35-degree angle. Yeah, that's bad. What do I do? Well, let's see, I'm 800 feet from Mount Rushmore, right? So notice that I need to find this side right here, and I need to find this side right here. Yes?
Another thing that's kind of unclear about the question is, are they asking how tall the structure is off the ground, or how tall the structure is from the bottom of the sculpture to the top of the sculpture?
Yeah, actually, I'm going to disagree with you on that one, Jesse. I agreed with you on the first one, but I think this one pretty much says, I want to know how tall his sculpture is. In other words, if you look at Mount Rushmore, what do you notice about the sculptures? I got a face staring out from the mountainside. There's no body. I don't care. Now, if this were talking about the sculpture in the Lincoln Monument, then you would have a case. So I'm going to have to shoot you down on that one, dude. But the other one, I agree completely and totally with you. It was a poorly worded question. Okay. Find the height of the sculpture. How tall is Abe's face? Okay, let's do that. Let's do this. Let's fix that. How tall is Abe's face? There we go. That takes out all the ambiguity. How do I find this one? Okay. I'm going to use tangent, and I note that I have two opposite sides. I've got an opposite sub 1, and I've got an opposite sub 2, right? The height of his face, AF, Abe's face, is going to be equal to the tangent of O sub 2 over 800 minus, no, I'm sorry, let me rephrase that. Let me rephrase that. It's going to be the tangent of, forget it. I'm just not saying it correctly. The height of Abe's face is going to be equal to O sub 2 minus O sub 1. So I need to know what they are, and I'm going to use the tangent function. The tangent of 32 degrees will be equal to O sub 1 over 800. Okay? So that means that O sub 1 is equal to 800 times the tangent of 32 degrees. And in addition to that, the tangent of 35 degrees will be equal to O sub 2, and that should be in purple, sorry. Divided by 800. And therefore, O sub 2 will be equal to 800 times the tangent of 35 degrees. Okay. And this other one should have been, it should have been in red. There we go. So just calculate O sub 1. We get 800 times the tangent of 32 gives me this. Now, I'm going to talk about something in just a minute. 8954 dot dot dot. Actually, that should be 5 if we round it off, but I'm not going to round it. I'm just going to truncate. And this one's going to be equal to 800 times the tangent of 35 degrees, which gives me 560.1660. Now, notice that I've done the calculations right here. What I should do, in order to get it as accurate as possible, is write it like this. The height of Abe's face is going to be equal to, and this is what I was trying to do originally, is 800 times the tangent of 35 degrees minus 800 times the tangent of 32 degrees. I could even factor the 800 out of that if I want, but this is what I should put into my calculator. If I've got 800 times the tangent of 35 degrees minus the tangent of 32 degrees, I end up with this. I get 60.27. I can't write today. and it keeps going, okay? Which is going to round, and what are we trying to round it to? The nearest tenth. So this is going to be 60.3. Now, the question I'm going to ask is, if I take 566 or 560.1660 and I subtract 499.8954, I get 60.2706. Now, while it doesn't matter in the tenth of a degree, it does matter if I were to go out to 10,000 or to 10,000th, because this is saying if I get 27.06 that I've rounded up incorrectly. Granted, the height of the sculpture, the round-off error is minuscule. I don't really care. But if I'm at Intel and I'm manufacturing my microprocessors, that is important. In fact, if you're in a mechanical engineering situation and you are looking at ball bearings, that right there can be the difference between a jet engine flying perfectly and catastrophic system failure. And I know what you're thinking. Yeah, come on. That's like, yeah. That's the difference between death and life sometimes, okay? That's why I keep harping on round-off error. I know it seems kind of ridiculous. You're like, yeah, come on, death, life, really? We're in a trig class. Eventually, guys, you're not going to be in a trig class. You're going to be designing a system, okay? And it could potentially cause life or death, depending on what you're doing. What about a laser sighting system on a surgical unit, robotic surgery? Are you willing to take the chance that you're off by 1,000th of a degree? Because that can be the difference between the aorta being sealed up properly and blowing it out and the guy bleeding out on the table. What? I try. I'm trying to hammer it home. It is important, okay? It is important. All right, let's talk about trigonometry and bearings. I will not lie to you. This is where the majority of you mess up on a test. Bearings kick your tails. Why? Because every one of you guys have one of these things. How many of you actually know how to read a map anymore? Road map, yeah. How many of you guys could be dropped in the wilderness with a compass and actually survive? Yeah. That's what this is about, bearings, okay? GPS is great. Google Maps, phenomenal. I use it all the time, but I also know how to take a compass and a topo map and find my way out, okay? Now, let's talk about trigonometry. How about we spell trigonometry right? Dude. There we go. All right. Bearings. Let's look at this. I'm going to draw a bearing. This right here is going to be off the north. It's going to come off 40 degrees. If I say what this is a bearing of north 40 degrees east. That means that I'm looking north and I'm going 40 degrees to the east. Okay? You will not write that as 50 degrees north of east. Okay? That's not how you're going to do that. Okay? Because where would I get 50 degrees from? The other half. Bearings are always done off the north and the south. Okay? Always. I can write this I can write it also as a bearing of 40 degrees east of north. That's the only two ways I can write this. Okay? It's either north 40 degrees east or 40 degrees east of north. Yes, Jesse.
Do some compasses have like an absolute scale where everything is referenced off north and it goes 360 degrees clockwise around the compass?
Yeah, compasses are always referenced off the north. If you look at a compass needle, it will be two-colored. It'll have red and white, or depending on whoever makes the compass. It also is going to have a rotary dial. And you can turn the dial so it's always pointed towards north, and you can get your bearing off of that. And we're going to talk about that as we move a little bit more. How can you make a compass if you don't have one? Yep, water, needle, cork, and a magnet too. Magnet helps. You don't necessarily need a magnet because if you run electricity through the needle, you can magnetize it. You can get all MacGyver on it, I know. And if you, for those of you who know who MacGyver is, yes, Jesse.
If you have enough time on your hands, can you make a sort of sundial and
Yes, you can, but that takes a long time. It really does. And generally speaking, the people who get lost in the woods, they're not the ones that know how to do that. The ones who don't get lost in the woods, that come out, even if something catastrophic happened, they know how to do all this stuff. It's those guys who get stuck, you know, amount, whatever, wherever, and you got to fly in with a rescue chopper, and the guy's going, yeah, I'm down here. Okay, you know. If it's like, yeah, I mean, that's the thing. If it's like, 30 minutes before it's getting dark and you decide you're going up a, 25-degree elevation trail, might as well just, cut your wrist there because, use a little bit of common sense. But anyways, let's look at this one. I want you guys to tell me what this is going to be defined as. How would you write that down? Everybody write it down on your paper. Yep. North 77 degrees west. What about this one? Yeah, that's not accurate. Well, neither is that 77, but... How would you write that one? South, 62 degrees, 11 minutes, 12 seconds, east. Okay? Pretty much, yeah. We're going to break this down into degrees, minutes, and seconds, just like you do on a clock. It's hours, minutes, seconds, degrees, minutes, seconds. You can break down feet the same way. Okay? Don't move. All right, now, let's look at a couple of problems here. I give you this diagram. Points of the compass, north, east, south, west. I have four letters on there giving you 4 bearings. Find the bearing from O to D. Don't shout it out. Write it down. I want to find a bearing from O to D. How would you write that down? Just like that. Or you could write it as 25 degrees east of south. Okay? What about the bearing from O to C? Whoops. South 15 degrees west, right? I'm not concerned about the 75 degrees here. I'm concerned about this angle off the south. And since this is a 90-degree angle total, 75 from 90 gives me 15, so it's south 15 degrees west. How many of you, when we first started thinking this, that this would be, you know, I'd be 75 degrees southwest? And people do that. They make that mistake, okay? The only time that you're going to talk about northwest, southwest, northeast, southeast is when you're looking at north 45 degrees west, south 45 degrees west, north 45 degrees east, and south 45 degrees east. Yes, we use northwest, southeast, northeast, and southeast as a shortcut. We know that it's 45 degrees off the north or off the south, either orienting east or west. When you say South by Southwest, what does that mean? And I'm not talking about the festival in Texas, okay? What does South by Southwest mean? Anybody, come on. Jesse can't be the only one that throws out answers. I wish I remembered it. Tate, where are you? No, I've already talked to you. Say that again? Yeah, when I go south by southwest, I'm moving generally in a south by southwest, so it's going to be somewhere between 0 and 45 degrees off the south towards west. Sorry, okay? And that's the same thing with north by northwest. Now, why did I choose those two? Yeah, because this is a wicked cool festival, and that's an awesome movie. All right, and if you've never seen North by Northwest, you should see it. It's phenomenal. Alfred Hitchcock at his best. You guys all know who Alfred Hitchcock is, right? Please tell me at least most of you know who Alfred Hitchcock is. Just because it wasn't made in the last 10 years doesn't mean that it is an irrelevant movie, okay? Checkpoint number 6. I know we only got a minute left. We'll finish this on Tuesday, but you guys, this won't take long. But yeah, we can't do this in a minute. All right, I'll see you guys. Make sure you